Good day and a very big welcome to the Aquaponics course on DVD. The introduction to aquaponics is simple. The problem is that there are too many people and too little food. Add to that the fact that other resources such as space, water and fossil fuels are becoming limited, and you can see where the problem lies. First of all, let's have a look at a video clip recently released by the World Bank entitled Rising Food Prices. Nearly 1 billion go to bed hungry. From that video clip, one can clearly see the importance placed on efficient agriculture and open access to markets as viewed by the World Bank. But if we have a look at these problems individually, the first of the global problems facing our population is in fact the population itself. The rate at which the population is growing is simply too fast for sustainability. If you have a look at the website www.worldometers.info, you will see the very rapid rate at which the population is growing in real time. The chart on the right hand side also shows how population was stable at well below 1 billion people until about the 1800s, at which point the population started growing extremely quickly. In the year 2000, there were about 6 billion people in this world. 2010 saw us increase by another billion people to 7 billion people, and the population continues to grow. Another major factor facing the world population is the decreasing supply of wild-caught fish. Be these from a marine or a freshwater source, we have simply overfished the wild stocks, such that the resource can no longer continue to supply the quantity of fish required to fill the plates across the world. Food shortages globally of all sorts are becoming a problem, and associated with food shortages is the rapidly rising cost and volatile prices associated with feeds. More and more, food quality or food healthiness issues are also becoming topical, and buyers want to know the quality and the healthiness of the feed that they are purchasing before they will commit to purchasing it. With a growing world population, the obvious result of land shortage is also a problem. And combined with this is water shortage, referring of course to fresh water. Power supply and the costs associated with power supply are also becoming a global challenge. And more people are looking towards renewable forms of energy. If we look at aquaculture as an industry, there are challenges within this industry itself. First of all, there are expensive filtration components. Secondly, the dissolved wastes produced by the fish or released by the fish accumulate within the system, and this cannot be allowed to happen. So we need to clean the filters on a regular basis, which means the waste produced by the fish, which is in fact a nutrient source, is dumped, and it's dumped with water. So we're losing the nutrients and we're losing water from the system on a daily basis. Also, with most aquaculture products, there's a fairly long waiting time to market. Typically, this would be in the region of 8 to 12 months. Hydroponics, on the other hand, has expensive nutrient solutions. The media is in bags or in pipes, and due to the small volume, can rapidly increase in temperature or decrease in temperature during the day. Furthermore, the flavors are also very bland of crops produced hydroponically. So what is aquaponics? Well, aquaponics is a combination of recirculating aquaculture technology combined with hydroponics in a single recirculating system. We feed the fish produce ammonia. The ammonia is converted from a very toxic form to nitrates, which are less toxic, by bacteria living within the system. Plants then utilize the nitrates, leaving the water clean to be returned to the fish. In this way, it is possible to have an aquaponic system where there is zero waste. Neither nutrients nor water are dumped from the system. Furthermore, depending on the design of the aquaponics, we can have a situation where the filter itself actually becomes the growing material for the plants, further reducing costs and simplifying the process. If we look at the simple input-output balance for aquaponics, the outputs we seek to achieve are fish and plants. In order to achieve this, we need to input water, light, feed, some labor, electricity, and trace elements, particularly chelated iron. There are certain very distinct advantages associated with aquaponics. The first of these is that we enjoy faster growth to market size than we do with field crops. Furthermore, production is constant throughout the year. We also experience fewer diseases than in field crops. Organic produce is a debatable point. The produce coming out of an aquaponics system can certainly be very healthy, depending on the medications that are used. But it cannot be labeled organic at this stage, because currently the people certifying products as organic require it to be rooted in soil, and aquaponics, by very definition of it, is not rooted in soil. The crop quality coming out of an aquaponics system is fantastic, and in my opinion, this is the biggest single selling point advantage that we as aquaponists have over other ways of culturing crops. Land requirement is also reduced because it's conducted very intensively, and labor requirement is also very low. The nutrients produced by the fish are utilized as plant food rather than being wasted as a problem. Water consumption is vastly lower than field crop production. No expensive hydroponic nutrients are required. The harvesting of crops, both the plants and the fish, is quick and easy. The operating expenditure of an aquaponic system is lower than for field crop production. There's no need to wash the crops. We have the ability to locate our aquaponics facility close to the markets because of its low footprint, low water consumption, and appropriate appearance. Crop management is far simpler than with soil crops, and crop rotation is not required. We do not have residual pest problems in aquaponics, such as nematodes. There is no weeding required. The occasional seed may blow in, but in essence, there are no weeds in an aquaponics system. Furthermore, for those of us who are entrepreneurial, this is a new industry globally, and therefore there are still lots of opportunities for those who are interested in being a little bit cute and willing to take a few risks. With any industry, there are disadvantages as well. For aquaponics, the disadvantages would be that the management must have a good working knowledge of both the fish and the plant crops. You need to be an expert in both. Pathogen treatment options are limited due to the potential negative effect on other crops. If our fish have a parasite, we can't necessarily treat with the same parasite treatments that we would use in aquaculture due to the potential impact those treatments could have on the plants, such as using salt in the water, because the plants won't survive when there's salt in the water. So again, one needs to be an expert on both to understand what the requirements of each crop are respectively. Just now I mentioned that aquaponics was a new industry, and therein lay an enormous advantage in terms of the potential for developing new things. Well, equally, the fact that it's a new industry means that this is a disadvantage as well, because much research is still required to refine and optimize techniques and technology used within this industry. If we consider for a moment the types of aquaponics, firstly, we have the nutrient film technique, or known as the NFT. In this method, there is no rooting medium. The plant's roots are simply hung through a hole in the top side of a horizontal length of piping. The roots hang through to the bottom of the pipe, and water trickles down the length of the pipe at a slow gradient. This water is just a thin film, hence the name nutrient film technique. Both mechanical and biological filters are required in this method. Mechanical filter to remove the solids that would otherwise block the roots of the plants, and a biofilter to house the bacteria which convert the ammonia into nitrate. This means that because there's a mechanical filter, there will be backflushing, so there is still wastage, and it increases the expense of the system. There is also always the risk with NFT of a power failure allowing the roots of the plants to dry out. Due to the thin film of water rapidly leaving, if there is a power failure, the pipe will then be dry and the roots will dry out very quickly. We're talking about on a hot summer's day, going from a thin film of water flowing to the electricity being cut to no water flowing and the plants dying. This can be in the region of 15 to 20 minutes only. Furthermore, the thin film of water flowing down the length of the pipe is in contact with the air inside the tunnel. During the day, the air temperature is very high. On occasions, it can reach 45 or even 50 degrees Celsius. At night, that same temperature can drop to 15 or 20 degrees. The thin film of water rapidly takes up or gives off heat from or to the air, and this results in rapid heating or cooling of the water within a nutrient film technology system, which is stressful both to the plants and the fish. My personal opinion is that I do not like NFT systems for aquaponics. Deepwater culture is the next option. Floating polystyrene sheets are placed on top of large, shallow tanks of water. The roots hang through holes in the polystyrene sheets into the water, and the water travels very slowly from the one end of the raft to the other. Mechanical and biological filtration is still required to remove the solids and to convert the ammonia into nitrates. And aeration below the sheets is essential to prevent low oxygen levels forming. This method is the least expensive of the three options and is therefore commonly used on a commercial scale. However, once again, because we need mechanical filters, there is a loss of nutrients from the system and there is a loss of water. The third option we can consider is the aggregate bed technique. In this option, we have 30 centimeter deep beds of gravel, typically 20 millimeter stone. Water enters the bed continuously or semi-continuously and drains continuously or semi-continuously to provide a flood and drain cycle. In other words, the bed drains so that there is no water within the bed, and then the bed slowly floods until the bed is almost completely full. At that point, it again starts draining, then it refills. Each cycle from full to empty to full again is about 15 minutes in duration. Because of this flood and drain cycle, the beds become very rich environment for bacteria, and the beds serve as the mechanical and the biological filters. This technique is the most variable in terms of the crops that can be grown, and it is medium cost to establish, not as expensive as NFT, but possibly slightly more expensive than the Raft option. An advantage here is that no nursery is required. Even small seeds can be planted directly into the stone beds. Crop options. By far the most successful crops in an aquaponics environment are your leafy crops, such as lettuce and basil. Fruiting crops are also successful where we have sufficiently high nutrient levels, and here we would include things such as peppers and tomatoes. Essential oils are also a possibility because of the intense flavor and aroma associated with crops grown in an aquaponics environment. Herbs such as basil, celery, mint, parsley, and so forth do extremely well in aquaponics. There is potential to grow ornamental seedlings and cut flowers, and one can also grow duckweed and other forms of fish feed. In summary, therefore, aquaponics is where veggies tasted as they did when we were children.